Are you working to calculate derivatives in calculus? Let's solve some common problems step by step so you can learn to solve them routinely for yourself. Derivative of x raised to n is given by nx raised to n minus 1. Derivative of a constant is 0. Derivative of x is equal to 1. You will also want to remember that 1 by x raised to n is equal to x raised to minus n. For example, 1 by x square is equal to x raised to minus 2, and nth root of x can be written as x raised to 1 by n. For example, cube root of x is equal to x raised to 1 by 3. In this slide, you can see the derivatives of exponential and logarithmic functions and also the derivatives of trigonometric functions. So the derivative of sin x is cos x is minus sin x, derivative of tan x is sec square x, derivative of cosec x is minus cosec x cot x, derivative of sec x is sec x tan x, and derivative of cot x is minus cosec square x. Notice that a negative sign appears in the derivatives of the co-functions cosine, cosec and cotangent. Here are given the derivatives of inverse trigonometric functions. In this slide, I have given the formulae of hyperbolic functions. Now let's look at the power rule in detail. That is, derivative of x raised to n is equal to nx raised to n minus 1. For example, derivative of x cube. So in this case, x cube, when we compare it with x raised to n here is 3. So nx raised to n minus 1 becomes 3x raised to 3 minus 1, that is equal to 3x square. Similarly, derivative of x raised to 47 is 47x raised to 46, that is 47x raised to 47 minus 1, that is equal to 47x raised to 46. Now two specific cases you will quickly remember are derivative of constant is equal to 0 and derivative of x is equal to 1. Now look at the question. Differentiate f of x is equal to 2 pi. Now derivative of 2 pi is equal to derivative of a constant. 2 pi is a constant. Therefore the answer will be 0. Now look at the next question. Find the derivative of f of x is equal to 2 by 3 x raised to 9. Now recall that derivative of x raised to n is equal to n x raised to n minus 1. So derivative of 2 by 3 x raised to 9 can be written as 2 by 3 into derivative of x raised to 9, that is 2 by 3 into 9x raised to 9 minus 1, that is 2 by 3 into 9x raised to 8, which can be further simplified and written as 6x raised to 8. Now look at this question. Calculate the derivative of f of x is equal to 2x cube minus 4x square plus x minus 33. Recall that derivative of x raised to n is given by nx raised to n minus 1. So in this question we simply go term by term. So that is, we differentiate the terms individually and add them. So that is, derivative of 2x cube minus 4x square plus x minus 33 is equal to derivative of 2x cube minus derivative of 4x square plus derivative of x minus derivative of 33. So derivative of 33, as we know, derivative of a constant is 0. So the last part becomes 0. So the next line can be written as 2 into derivative of x cube minus 4 into derivative of x square plus derivative of x. So that is 2 into derivative of x square is 3x square. Derivative of x cube is 3x square. Derivative of x square is 2x and derivative of x is 1. So simplified, we will get the answer 6x square minus 8x plus 1. Now differentiate f of x is equal to root x. So recall, nth root of x is equal to x raised to 1 by n. And also derivative of x raised to n is equal to nx raised to n minus 1. The rule also holds for fractional powers. So derivative of root x can be written as derivative of x raised to 1 by 2. That is 1 by 2 x raised to 1 by 2 minus 1. That is 1 by 2 x raised to minus half or it can be written as 1 by 2 into 1 by root x. So it will be useful if you study that derivative of root x is equal to 1 by 2 root x. Next question, differentiate f of x is equal to 5 by x cube. So recall 1 by x raised to n is equal to x raised to minus n. Also derivative of x raised to n is equal to n x raised to n minus 1. The rule also holds for negative powers. So derivative of 5 by x cube can be written as 5 into derivative of x raised to minus 3. That is 5 into minus 3x raised to minus 3 minus 1. That is equal to minus 15 x raised to minus 4, which can be written as minus 15 by x raised to 4. So next question, differentiate f of x is equal to 2x square plus 1 the whole square. So in this case it would be easy if we open the bracket and square the terms. So we'll use the formula a plus b the whole square is equal to a square plus 2ab plus b square. So that gives us this. Simplifying it, we'll get 4x raised to 4 plus 4x square plus 1. We can now take the derivative. So the derivative is equal to derivative of 4x raised to 4 plus derivative of 4x square plus derivative of 1. So the last term is derivative of a constant is equal to 0. And then the first term can be written as 4 into derivative of x raised to 4. That is 4 into 4x cube. And then 4 into derivative of x square. That is 4 into 2x. Simplifying it, we will get it as 16x cube plus 8x. So next question, differentiate f of x is equal to e raised to x plus x. So we can differentiate term by term. Derivative of e raised to x plus derivative of x, that is equal to e raised to x plus 1. Now next question, calculate the derivative of f of x is equal to e raised to 1 plus x. So recall that a raised to n plus m is equal to a raised to n into a raised to m. Hence, e raised to 1 plus x is equal to e raised to 1 into e raised to x. And remember that e is just a number, a constant. Hence, derivative of e raised to 1 plus x is equal to derivative of e into e raised to x. So because e is a constant, we can write it as e into derivative of e raised to x. That is e into e raised to x or e raised to x plus 1. Next question, differentiate f of x is equal to sin x minus cos x. So that is equal to d by dx of sin x minus d by dx of cos x. That is equal to cos x. So derivative of sin x is cos x. Derivative of cos x is minus sin x. So final answer is cos x plus sin x. Now calculate, next question, calculate the derivative of 5x cube minus tan x. So that is equal to 5 into derivative of x cube minus derivative of tan x, which is given by 5 into derivative of x cube is 3x square. Derivative of tan x is sec square x. So 15x square minus sec square x is the final answer. Now let's look at the product rule. That is, if you have to find out the derivative of product of two terms. So d by dx of f into g is given by d by dx of f into g plus f into d by dx of g. Or you can also state it as derivative of first into the second plus the first into derivative of second. So differentiate f of x is equal to x sin x. Since the function is the product of two separate functions x and sin x, we must use the product rule. Recall that derivative of x is 1 and derivative of sin x is cos x. So let's see how to apply the product rule. So derivative of x into sin x is derivative of the first function into second function plus first function into derivative of second function. So derivative of x is 1 into sin x. X into derivative of sin x, that is cos x. So that is equal to sin x plus x cos x. So next question. Calculate the derivative of f of x is equal to e raised to x plus 1 into tan x. Since the function is the product of two separate functions, e raised to x plus 1 and tan x, we must use the product rule. Derivative of e raised to x plus 1 is e raised to x and derivative of tan x is sec square x. Now using the product rule, derivative of e raised to x plus 1 into tan x is equal to derivative of e raised to x plus 1 into tan x plus e raised to x plus 1 into derivative of tan x. So that is e raised to x tan x plus e raised to x plus 1 sec square x, which can be written as e raised to x tan x plus e raised to x plus 1 into sec square x. So that is the final answer. Now let's look at the quotient rule. The quotient rule, derivative of f by g is equal to derivative of f into g minus f into derivative of g divided by g square. You can also study it like this. Derivative of numerator by denominator is equal to denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. Now look at this question. Differentiate f of x is equal to sin x by x. So d by dx of sin x by x. Since the function is the quotient of two separate functions sin x and x, we must use the quotient rule. Recall that derivative of sin x is equal to cos x and derivative of x is equal to 1. So d by dx of sin x by x is equal to d by dx of sin x into x minus sin x into d by dx of x whole divided by x square. So that is cos x into x minus sin x into 1 whole divided by x square, that is equal to x cos x minus sin x whole divided by x square. Now next question. Calculate the derivative of f of x is equal to e raised to x whole divided by x plus 1. So that is derivative of e raised to x by x plus 1. So here also the function is quotient of two separate functions, e raised to x and x plus 1. So we must use the quotient rule. So by quotient rule we get d by dx of e raised to x by x plus 1 is equal to d by dx of e raised to x into x plus 1 minus e raised to x into d by dx of x plus 1. So that is equal to e raised to x into x plus 1 minus e raised to x into 1 whole divided by x plus 1 the whole square. So we can take the e raised to x outside and e raised to x into x plus 1 minus 1 divided by x plus 1 the whole square. So the final answer is x e raised to x whole divided by x plus 1 the whole square. Now let's look at another problem using the quotient rule. Find the derivative of f of x is equal to 3x whole divided by 5 minus tan x. So d by dx of 3x divided by 5 minus tan x. So here also the function is the quotient of two separate functions 3x and 5 minus tan x. So we must use the quotient rule. So d by dx of 3x whole divided by 5 minus tan x is equal to d by dx of 3x into 5 minus tan x minus 3x into d by dx of 5 minus tan x. So we get it as 3 into 5 minus tan x minus 3x into minus sec square x whole divided by 5 minus tan x the whole square. So on simplification we get the answer as 15 minus 3 tan x plus 3x sec square x whole divided by 5 minus tan x the whole square.